Let's go over some of the homework that I had you guys do today, and noticed and yesterday noticed there's a lot of confusion, and some of you need help. So I want to go over the answers to these problems. So the question one: what is the pH of a 0.5 molar solution of nitric acid? So this is the strong acid. Sorry, whenever I start writing here, it kind of looks messy. Strong acid is 100% dissociation. So if I have 0.5 molar nitric acid, that means I'm going to have a 0.5 molar H plus and a 0.5 molar concentration of nitric acid. And if you remember, pH is just the negative log of the concentration of H plus. I don't know what the heck's going on up there, but it's driving me crazy. So for this one, you would take the negative log of 0.5, and the negative log of 0.5 is 0.3. So that is the answer. 0.3 is your pH of that one. All right, let me erase this. Yeah. All right, next question. What is the pH of a solution? The pOH is 8. Remember that pH, wrong. There we go, let's do blue. pH plus pOH equals 14. And this has to do with logarithms. If you want the background, you can look it up. But that's a shortcut. So if pOH is 8 and it equals 14, as you do subtraction, my pH is going to be 6, which is slightly acidic. That was an easy one. Get rid of this. Get rid of this. And let's do the next one. Next one, benzoic acid. Has a Ka of 6.3 times 10 to the minus 5, and boric acid has a Ka of 5.8 times 10 to the minus 10th. Which one is a stronger acid? So we're looking at the Ka. This is all based on Ka. And remember, for equilibrium, we have 10 to the minus 5, 10 to the minus 10. It's product over reactant. Here, the smaller number indicates a stronger acid. So boric acid is going to have it's going to be significantly stronger. No, I'm sorry. I'm misreading my own question. Benzoic acid, which is the one at the 10 to the minus 5, is going to be a much stronger acid than boric acid, since it's 10 to the minus 5 versus 10 to the minus 10. So you're going to have more H plus and benzoic acids dissociated versus boric acid. And again, for more details, you can always go to the last presentation that I gave you, I suppose. All right, let me get this. Why isn't it working? No. Here I was trying to be all fancy and had technical problems there. All right, so the next question. Calculate the pH of a 0.7 molar solution of boric acid, Ka of 5.8 times 10 to the minus 10. And there's the equation, H3BO3. And it's a weak acid, so we're at equilibrium of H plus. And then we have H2BO3 minus, which is conceivably it would be a polyprotic acid. So we can have our equilibrium expression. So I have Ka equals H plus times H2BO3 minus, all over the original acid, H3BO3, and their concentrations, right? So what you're going to do for this one, I would suggest you do kind of your ice chart as your beginning. So initially I have 0.75 molar of H3BO3. I've got 0 H plus, H2BO3 is 0. My change is minus X, and with these 1-to-1 ratio ones, you get into this pattern, this rhythm. I mean, it's pretty constant how they go. It's going to be plus X, and then at equilibrium, you put it together. You have 0.75 minus X, you have X, and you have X. Then you substitute back into the equation. My Ka, remember, is 5.8 times 10 to the minus 10. That's going to be equal to X times X all over 0.75 minus X. Now, the real key to this is that this X drops out of my equation. Right, if you want to be proper, you can do using the quadratic formula. You're going to end up with the same answer, and it saves you a lot of time. So this one we're going to drop. Drop that x, drop it, and it makes this equation and this math a lot easier. So now I'm going to take 0.75 and multiply it by both sides. It'll cancel this 0.75 out. And let's see if I have written it down. I did not. Well, when you get to it, you end up with, here, let me do it real quick. Get my old calculator out. The old TI-30XA. 5.8. I mean, it's amazing how quick you can get things done in this calculator. All right, so that equals 4.35 times 10 to the minus 10 equals x squared. You're then going to take the square root of both sides. And when you take the square root of both sides, you get 0.0021 equals x, which you remember is my h. So now it's h plus. The question is actually asking for pH. So I want to take the negative log of 0.0021. That is going to be my pH, which in this case is 2.68. All right, that's going to be my pH. Remember, pH is negative log of the concentration of H+. I'm going to get rid of this and do the final problem we had for yesterday. And get you prepared. Let's get rid of this. See, now I'm going to try and look at that fanciness. Had a nerd moment today. Talking about unit conversions with the little kids. It's fun. Talking about moles. How big moles are. They were blown away by the size of a mole. And the fact that it wasn't just a little creature. All right, so phenol. pH of we want to determine the pH of 1.5 molar solution of phenol. I did not give you the equation, but you can kind of see the pattern here. Or you could have looked it up. But why would you do that, right? Why would you look it up? All right, so equilibrium, you have H plus C6 H5O minus. You're going to end up with Ka of 1.3 times 10 to the minus 10, and equilibrium is going to be H plus times C6 H5O. You get the point. HC6 H5O. These are all very repetitive. All right, so I have 1.5 molar solution. All right, I'm going to do my ice chart. Initially, I have 1.5 molar solution of phenol. Again, it's not 100%, so I don't know how much it's going to dissociate, but initially I have 0 there. I'm going to have X amount lost, right? X amount is going to dissociate, which means that I'm going to gain X amount of H plus and gain X amount of C6H5O. Again, 1-to-1 ratio. So whatever the split apart happens here or dissociation happens here will result in equal amounts of product. So at equilibrium of 1.5 minus X, I have X, I have X. I go back to my equation. 1.3 times 10 to the minus 10 equals X times X all over 1.5 minus X. What do I do with this X? I drop it. And I didn't write down. I kind of skipped ahead in my calculations doing the problem. So you end up, when you multiply each side by 1.5, you end up with 1.9. Goodness, 1.5. There's these buttons. Oh gosh. There's these buttons on this pen that I'm using that are screwing me up. It's not made for a lefty. 1.5 times 10 to the minus 10 equals X squared. You take the square root of both sides, and you get 0.0014, if I read my handwriting right, equals X. That's not answering the question. I need the pH. I need to take the negative log of 0.0014. Negative log of 0.0114 is 2.85, which is my pH, which is very similar to the last problem, off by a little bit, but hopefully this helps. Again, it's practice, but with these equilibrium acid-base ones, it's pretty, you get into the same pattern going, where you have the 1-to-1 ratio, X squared on the top, something on the bottom, you drop the X, and then you really, it gets pretty, once you get into the rhythm, it's pretty simple. All right, well, hopefully that helps, and good luck practicing it today.